Hi, good morning, and welcome to the ZP vlog and podcast. So we like to do this every Sunday at approximately 8 a.m. And I'll essentially jump straight into it. So we just like to say put out our news and sort of do a wrap up for the week. So one of the things that we did talk about this week was actually the measurement of capsaicin in chilies. So there's a standard out there. At least three organizations, one in India, one called ASTA, and another one called AOAC. They have these different methodologies, which generally rely on HPLC to measure capsaicin. It's very interesting because people hold these, in high regard, and these organizations are good organizations. But when you actually dig down into it, the methodologies that people are kind of relying on or believing in, let's say, are actually they're not validated necessarily from actually measuring chilies. So one of the things that goes on in this world, there's a lot of sort of chili and chili powder usage in India. People use the AOAC method for actually measuring the capsaicin in those chilies. But when you read the AOAC method, it's written there, it says not for chili powder. So it's almost like a sort of, it's a test that's being used, but it's actually not validated for actually measuring the sample type that's actually being used. So it's kind of interesting when you dig into these things and you sort of find out the details on what's actually going on within an industry. So that was something that we discovered or we've realized of recent. But I'd say this kind of happens quite a lot in the world. Actually, you can have a lot of people all sort of doing something, and it's kind of ingrained within the culture or the norms of that industry, and then actually you can discover. I've done this a couple of times where actually there's an error, let's say, and it sort of sometimes invalidates what's actually going on. Something else that we've talked about a little bit more this week as well is really our biosensor developers evaluation kit, EVK. So in electronic engineering, they really like to have an EVK, an evaluation kit. We do have such an evaluation kit, at least for our electronics, called our single purpose biosensor circuit. It's a bit of a mouthful. I think EVK is a little bit easier to say, but we do have this. I mean, it's very elegant, in terms of, one of the powers of electrochemistry is really the electronics can be very small form factor. Look at any glucose meter, look at any wearable glucose sensor, which is called CGM, continuous glucose monitoring, and you find very small set of electronics there. So that's one of the elegances of electrochemistry, and we do have an EVK kit for that kind of work. Something that, this is just a general statement, but electrochemistry, I think it touches upon that piece, my comment earlier on, that electrochemical sensors can actually be intrinsically very small. And actually you can get quite a lot of signal from them. So for example, a fiber optic is intrinsically small, and you can get good signal from it. But electrochemistry is almost more so, because with electrochemistry, the signal we're getting is electrons, where with fiber optics, they have to sort of excite and generate photons, and then its photons are essentially the signal back for them as well. So electrochemistry does really offer you a very small sensor. And I think this small sensor and the fact that you can use small electronics is really kind of changing the game. I think I kind of call it the smart bioedge, where you can use this kind of sensors now in environmental monitoring, health applications, agriculture applications, food and beverage, and I don't want to say you name it, but essentially where else can we go with these things? And I suppose that will come along in a minute when I talk about actually smart packaging, because people really are sort of naming things. We just did a quick webinar just now, in fact, really about measuring soil health. So that is one of the obviously applications that's for biosensors as well. And there we talked about NPK, nitrate, phosphate, potassium, but also sodium, ammonium, urea, pH, and TAS, total antioxidative status, all as markers for actually measuring soil health. I just mentioned it as well that that biosensors are sort of changing the game, and one of them I think is actually smart packaging. I think this is really something that's kind of maturing at this point. So if you want to measure an analyte or property of a solution, then electrochemical biosensors really offer up an ideal solution, because they're intrinsically often printed. The kind of parameters that they can measure, be it pH or salinity or conductivity, they intrinsically measure even redox potential, which is an indicator of antioxidative properties. Electrochemistry really offers it. And again, that sort of part where electrochemistry can also be driven by small electronics and small power electronics as well also lends the methodology to doing things like smart packaging and understanding the state of the material within that packaging. And at ZP, we do have the SensiAll platform, so that means that we really can get from sensor to cloud really effortlessly. So this is the kind of IoT of packaging, or the Internet of Things of packaging, I think is really here at this point. So that's something that we have discussed this week as well. I suppose therefore we describe it as kind of QR enabled sensors. And QR enabled is sort of because the sensor itself can be printed. The QR code that kind of enables that sensor to be used is also printed. So we have a very kind of, printing appears several places in our technology stack, and that, I'm not going to call it irony, but that importance is actually not lost upon us. We have put a lot of information out there this week really about glucose sensing, because we do think that glucose sensing or glucose strips, even though that's a very commoditized technology these days, and by commoditized I mean, you wouldn't necessarily start a glucose strip manufacturing company, because really the only thing you can compete on in these days is price, and so it's sort of a race to the bottom. But that we can learn a lot of lessons from the glucose strip. And so we put some sort of images up this week describing the layout of a glucose strip. We put out images actually talking about the cross section of a glucose strip. If you cut a glucose strip across in two different points, you'll get different essentially materials, but we have sort of described that. And we've already really talked about actually translating glucose strip manufacturing into other biosensor manufacturing, and we did definitely put a video out about that. And I think it comes back to earlier on I was saying that one of the benefits of electrochemistry is small sensor sizes possible, scaling of manufacturing is proven by the glucose strip, the electronics can be really low cost, look at any glucose meter, and actually the volume size can be very small as well, like 300 nanoliters is a typical glucose strip volume. So these are all the sort of bits and bobs of information that we've put out there this week. I think that with that, I'll sort of leave it and say, we're going to have our vlog and podcast again next week. If you have got any questions of ZP, please don't hesitate to reach out to us. I think it's www.zimmerpeacock.com/contact, and you'll find us. But as I say, any questions, don't hesitate to reach out to us. Okay, thanks very much.